have time in class for you to work on it, and then your homework will be due tomorrow. We're doing rational functions. We finished off on the example. We're going to do the next example because I want to show you something with a b value. I want to show you something with a b value. We're going to keep it as, or we can take a look at it both ways actually. So we're on this example here. We're going to talk about how it's translated, or how it's transformed, I should say. And then we're going to, yeah, we did. Okay. Caught up to him? All right. Something I noticed, sixth period. Guys, believe it or not, a vertical stretch, normally in every other function we've had, a vertical stretch resulted in a horizontal compression and vice versa. A vertical compression ended up with a horizontal stretch. However, I didn't realize it at the time, just wasn't thinking about it. Sixth period pointed out that in this case, a vertical stretch is a horizontal stretch, and a vertical compression is a horizontal compression. Because of the symmetricness of the vertical and the horizontal, because of the fact if we look at it really quick, but without looking at this one here, my rational functions kind of look like this. If I pull it vertically this way, it ends up getting pulled horizontally that way. So because of the fact that it has to remain symmetric along this point. So if I pulled it this way, it also ends up getting pulled. So stretches go with stretches, and compressions happen to go with compressions on this here. So with this, let's talk about this. We're going to keep this as a b value. We're not going to change it to an a value. We are not going to change it to an a value. Yes. This is Mr. Bates. Hey, what's up? Oh, okay. Well, I was out, and so my wife just had paper attendance. Oh, yeah. Oh, it's other classes. Oh. Oh, okay. No worries. So I'll be able to now. All right. Okay. All right, will do. Thank you very much, Ann. Bye. All righty. So, really quick, guys. All right, so here we've got a b value of 0.5. Now, when we do b values, we still have to flip them. We still have to flip them to know what really happened. So 0.5 is what, and so our b value. Is everybody okay, since it's the multiplication in the denominator? That makes it a b value. So our b is going to be 0.5, right? Yeah. So flip that, Miss Ya. And what do I get?
1 over 2.
It already is 1 over 2.
2 over 1.
I get 2, yes. So this is 2.
I did it right.
All right. So this is a horizontal stretch. Horizontal stretch by 2. And for those of you who got lost there, I wanted to get those kids that could do it mentally first. Okay, a b value of 0.5 means a b value of 1/2. And whenever we do, since it's technically in the denominator, I need to flip it. Gentlemen, I'm gonna have to move us, I think, to this corner over here, get you guys a little closer. And there's no debating it. I meant to put in a seating chart for this semester as it is. Okay, so our b value is 1/2, so we flip it to get our horizontal stretch of 2 over 1, which is 2. And then we have a vertical. We've moved up by how many? 3. 3. And I like the German 3 over there. So if you guys weren't aware, the majority, I'm not speaking for you ladies right now, it's this. The majority of, as far as I know, Europeans, they start counting like this. They don't do this like Americans. They don't put this up, this up, this up. They do this.
Yeah, I don't understand why we count.
Yeah.
Yeah, I
Majority of Americans start with their pointer finger. I don't know. Okay. So, all right, guys. Let's go ahead and get our.
Wait, you forgot the left.
Huh? I didn't move left. Oh, left one, huh? Thank you. Thank you. Left one. So up 3, left 1. There were some I wanted to give yesterday and I forgot. So remind me when I give you guys time to do your work. So we've got a horizontal stretch by 2. So I'm going to go out 2, up 1. We'll get that far.
Oh, mira la señora. Let me find it.
Yes, ma'am. It can. You turn on for the Apple Watch. You turn it on to waterproof mode, and then when you turn it, when you say you're done being in the water, it ejects the water that has gotten into it.
Can you use it as a
Are y'all serious? Y'all just was that just a whole
No,
joke? I wasn't a part of it.
I'm serious. It's waterproof. I can take it swimming.
So like, there's this button and it's going makes.
I want to hear about this.
Questions here, guys. Let's go over it again. I horizontally stretched by 2 because I had this 0.5. It was down below instead of out left, which would have made it an A value. So I had this B value of 0.5. I turned it into a fraction and flipped it to get what my horizontal stretch or compression was. It moved up 3 because of that K value out there, and it moved left 1 because of this value right here. So I moved my asymptotes left 1 and up 3. And then with that horizontal stretch of 2, instead of being that spot right there, I went up 2 over 1, out 2, up 1, and those were the dots I had to hit. Because it's been stretched by a factor of 2. Normally, when you do these rational functions, they go through up 1 over 1, and it just goes through that spot right there. But when you have a higher value, it brings it out and away a little bit. It'd be, if it was vertically stretched, it would look the exact same, actually. It would look identical. Okay? Looks like I didn't put more workbook work in, and there's a reason for that. So the workbooks did something, and I don't know why. I double-checked. Oh, the range and stuff. Thank you so much. Missed it. Wow, you guys. All right. I hear you. Okay. Right. So the first one was inequality. Inequality notation, set notation, and interval. Thank you. Couldn't think. No, now we're getting crazy. And we're doing domain and range.
Because if it's more than one, it's a stretch. And if it's less than one,
Correct. I don't know who you're talking to, but that is a correct description.
I found Sydney. Hero points.
Ladies.
Sorry.
Exposing my retardness.
Whoa. Do not use that word, Sydney. Okay. Inequality notation for my domain. Inequality notation for my domain. I'm going to make Martina, since she's over here with her hero points.
What?
Miss Pele.
Inequality
X.
Cannot.
We can do that for set notation, but we're not going to do it for inequality.
Less than.
Less than. Negative. 1. And
X is greater than
x is greater than
negative 1.
negative 1. Because I can't be negative 1. I look at my vertical asymptote for my domain. I look at my vertical asymptote for my domain. For my range, Martina.
Y.
Y. Greater than.
Yes. That one. 2. No, 3.
3. And
Y.
Y.
The other.
Less
Right?
than.
Yes.
3. Leticia. Leticia, set notation. Brace. Huh?
Is that really what that's called?
X. A brace, yes.
That one.
X. Not equal to. Negative 1. Yeah. And brace. Y. Such that. Y. Not equal to 3.
I can only draw it like, I can't draw it going like this. I can only draw it if I turn my paper side to draw it. It's so hard to draw any other way.
Interval. Gabriel. Parentheses. Negative infinity. Comma. Negative 1. Parentheses. The U. Parentheses. Negative 1. Infinity.
That's Alexa's favorite one right there. She only raised her hand for this one.
I already extolled your virtues during 6th period yesterday to say that you amazed me and you got it. And I was surprised that somebody got it so easily. So.
That's because I have big.
And then they were like, who was it? Josiah? And I was like, no, it wasn't. They were like, Gabriel? No, it wasn't. They ran through like, I don't know, 18 other people. And then they. And at no point were they like, and then I was like, no, it was Alexa. And they were like, really? Man, it was cruel. It was terrible.
Tell them that next time they come up to me asking me to help them with their notes.
I'm joking. You know I'm joking.
I know they probably would, yeah.
Anyway. All right. Adrian, why don't you give me the range one for this one here? 3. Infinity. Infinity 3. Negative infinity. Negative infinity 3. There we go. All right. Now we can move on. Were there any questions on that, folks? We're going to have lots of practice here in class to get started. Okay. These ones. Rewrite in standard form and graph it. So here, for especially Layla, who wasn't here for this lesson, I would say Marion also, but he's not here. No, Marion.
Marion Mosby.
Okay. I'll have to ask him if that's really his Czechoslovakian name, and if not, ugh. And then his last name is Brzon. So, obviously it's pronounceable. All right.
But they say it different, like the
Refocus. Dylan, Michael. Okay. This one, folks, we can. We'll wait a second for Sydney to compose himself. Shh. I know, did. I know.
Oh, and it was that part right there where your ankle is the little bone.
Hero point. Okay. So.
If you would have named the bone,
All right, guys. This one, we can't look at this. We can't say this is moved to the left one, that it's like has a vertical stretch or anything, or that it's moved up or down. We can't just look at it and tell. It's very easy to get there, though. We have to just simply do the long division. If we do the long division, it will pop out looking like the other problems we've done. This only works. This is only going to work when they're both power 1 in the numerator and denominator. The exponent here is 1. The exponent here is 1. This is the only time it's going to work. So we're going to do the actual long division, folks. So x minus 1 goes into 2x minus 4. And I'll pause for a second. And those of you who are from, if they're not going to give you that in this lesson. So don't worry. There are rules. There are other rules. This is only going to work for this simple lesson right now. But we're going to get into some of those other rules in the next section. Alexa? Thank you. Huh? Right. So let's go ahead and Jaden will do it together. What do I need to, what is x times what makes 2x? 2. Yeah. So, you guys? I'd appreciate it. Okay? Just do 2x divided by x. 2x divided by x is 2. So I put my 2 up front, and we're following the standard division algorithm. So now that I did 2x, this number here, divided by x. I didn't worry about the minus 4. I don't worry about the minus 1. 2x divided by x is 2. So now in normal division, I multiply. 2 times x, 2x. 2 times negative 1, negative 2. And then what would I normally do when I'm dividing? Subtract. So now I need to subtract this expression from this one. So subtract, put a parentheses down.
No.
Negative 4 minus negative 2. Okay. Negative 2. Negative 4 minus negative 2. So that's negative 4 plus 2. Negative 4. So my remainder is negative 2. So I'm here. I am here. Does anybody have any questions about the long division before I move it on? Okay. It is technically speaking in the same form now. I'm going to put this out front. Does anybody have an issue if I put 4 minus 8? Negative 8 plus 4. What's the difference between these?
Nothing.
There's no difference. I can change the order that I add and subtract as long as I keep the signs in front. So what I can change this to is negative 2 over x minus 1 plus 2. Now I can bring that 2 out front, just like I did on that very first example. Negative 2.
1 over x minus 1 plus 2. Oh my gosh.
So I moved 1 to the right and 2 up. I've been vertically reflected because of that negative. Vertically reflected because of the negative, and then I'm also stretched by 2. And I'm done.
So it goes to the right to one.
When you go to check the time, but a text comes through at the same time, so you can't check the time. That is a first world problem.
When you actually have people hitting you up.
Sydney, that is your make-believe problem, because that doesn't happen in your world.
You don't want to know.
All right, I'm going to